This video is going to show you how to graph rational functions, and it follows along with the 12 steps that I've posted on Canvas. So step number 1 is to factor if possible. So we're looking for things that multiply to -8, but add to be +2. So the top part of this fraction factors into x plus 4 times x minus 2. And we do the same thing at the bottom. What multiplies to -2 but adds to be -1. So that is x minus 2 times x plus 1. So first step, we have factored. The second step is to cancel any common factors. So I can see that I have an x minus 2 at the top and the bottom. So I'm going to cancel those out. And our equation becomes x plus 4 divided by x plus 1. That is our simplified equation that we're going to use to do the rest of the properties. So that was step number 2. Step number 3 is to find the vertical asymptotes. So we are going to set the bottom of our simplified equation equal to 0. So we have x plus 1 equal to 0. Subtract 1 on both sides, and you get x is -1. That's our vertical asymptote. And you can put that on the graph as you're doing the properties or at the end. I'm going to put it on my graph as I'm doing the properties so that way you guys can see it. It's a dotted or dashed line at x equals -1. Step number 4 is to find the whole. So in order to find the whole, you take the term that you canceled out and you set it equal to 0. So I canceled out that x minus 2 up in that original equation. So I'm going to take x minus 2 equals 0. Add 2 to both sides. You get x equals 2. But you're not done. That's just the x value of the whole. So I need to find that y value. So what you do is you take your simplified equation, x plus 4 divided by x plus 1, and you make all the x values 2. You plug in a 2. So then you get 2 plus 4 divided by 2 plus 1. So that's 6 divided by 3, which is 2. So my y value in this case is 2. So I'm going to put the whole on my graph at 2, 2. So if you need to zoom in, you're drawing an open circle at those coordinates. Right, on to step number 5, the horizontal asymptote. For the horizontal asymptote, you're going to be using the simplified equation. This is the only one that it would also make sense to use the original equation. They both give you the same answer, so it doesn't really matter. So I'm going to take that simplified equation, and I'm going to be comparing the highest exponents. So we look at our highest exponents. There is not an exponent at the top or the bottom, but there is an x. So we can assume that those exponents are 1. So in other words, they have the same highest exponent. The top is the same as the bottom. So we need to make a fraction with the leading coefficients. The leading coefficients are the numbers before the term with the highest exponent. So there's no numbers here, so we can assume again that it's 1 over 1. 1 divided by 1 is 1. So our final answer for horizontal asymptotes is y equals 1. So I'm going to go ahead and put that on my graph as well. Horizontal asymptotes at 1. It's a dotted or dashed line. Step number 6 says to find the oblique or slant asymptote. But those only exist if there is no horizontal asymptote. So I'm going to write it in here just so you can see. To find the oblique asymptote, we are going to say there is none because it had a horizontal asymptote. If the horizontal asymptote was none, then we would need to do that division. Next, I'm going to find the x-intercepts. These are also called zeros. To find the x-intercepts, you set the top equal to 0. So you take x plus 4, set it equal to 0, subtract 4 on both sides, and you get x equals -4. And you want to write it as a number, comma 0. So I would write it as -4, comma 0. And I can also put that on the graph. All right, that's a closed circle because it's an actual point on our rational function. So -4, 0, I'm going to put a point. Next, I have to find the y-intercept. For the y-intercept, you are going to make all the x's equal to 0. Again, in your simplified equation. So I have x plus 4 divided by x plus 1. I'm going to make both of the x's equal to 0. So that's 0 plus 4 divided by 0 plus 1. That's 4 over 1, which is a positive 4. And you're supposed to write that as 0, comma a number. So 0, comma 4 is my y-intercept. We can also put that on the graph. Also a closed point, just like that. Now, if you need to find the domain of your function, find the domain, it is always going to be all real numbers, except x cannot be equal to the vertical asymptote, which is -1, and the x-coordinate of your whole. And our whole, the x-coordinate is 2. The last thing that most people ask you to find are the limits. The limit as x goes to infinity of f of x. These are always equal to the horizontal asymptote. So if I look back at my horizontal asymptote, I get 1. And as x approaches -infinity of f of x, it's also the horizontal asymptote, which is 1. You might be wondering what happens if you do not have a horizontal asymptote, and we'll do that next. So step number 11 is to sketch the graph. I've already put on the vertical asymptote, the horizontal asymptote, the whole, the x, and the y-intercept. So as you can see, I've kind of split my graph into 4 quadrants. Right? I have a vertical line here, I have a horizontal line here. Now, you don't want to cross those asymptotes. So what we're going to do, if I can find a different color, we're going to use gray. You see up in this first quadrant, we have 2 points. So you want to connect those points with a curved line that does not cross the asymptotes. We're just sketching a graph. Now, if I put a curve in this top right-hand quadrant, that means that I need to go across from it and put the other curve in the bottom left quadrant. They're always across from each other. So the same thing, you go through any points that you have, and you want to hug those asymptotes. So here we have a sketch of our original function. You can always check your graph with a calculator or Desmos. I don't think that they show you the holes, but it at least gives you an idea if you graphed it correctly or not. So we can look at what it would look like in Desmos. It was a fraction. Say you want to go to we can put it in parentheses. We could have x squared, and then it was plus 2x minus 8. So that's the top. Just hit divided by to make it a fraction. And in the denominator, we had x squared minus x minus 2. Yep, okay. So as you can see, it has our x-intercept, which is at -4, has our y-intercept, which is at +4. It does not show you the whole, which was at 2, 2. It does, however, if you go to 2, 2, it tells you that 2 is undefined at that point, which makes it a whole. Then you can see how it does not cross the vertical or horizontal asymptotes that we made. Now we're going to do an example that has a slant asymptote. We're going to follow the same steps though. The first step is to factor. So I'm looking for things that multiply to 4, but also add to 4. So in this case, we have x plus 2 times x plus 2. In the denominator, we have x plus 3. So I have factored, but nothing has canceled. That we don't have any common factors to cancel out. So then we can keep going. We can find our vertical asymptote, where we set the denominator equal to 0. Subtract 3 on both sides. You get x equals -3. Now I'm going to put that on our graph over here. Remember, it's a dashed or a dotted line at x equals -3. Next, we're going to find the holes. And to find the holes, we take the canceled out term and set it equal to 0. But I couldn't cancel anything out. So what that means is that there are no holes. The fifth step is to find the horizontal asymptote. So for the horizontal asymptote, you're comparing the highest exponents. And in this case, it might be easiest to use that original function. Because in that original function, I can see that the highest exponent at the top is 2. And the highest exponent at the bottom is 1. So we know that the top has the bigger, higher exponent. And in that case, that means that there is no horizontal asymptote. There's none. So next you have to find the oblique or the slant asymptote. That would be step number 6. Now for an oblique asymptote, it's easiest to use the original function. and you want to put the top inside the division sign right there. So you have x squared plus 4x plus 4. We're going to be dividing that by x plus 3. So right now you're looking at how many times does x go into x squared? Or another way of thinking about it is x times what gives you x squared? And that's just x. So x times x is x squared. X times 3 is 3x. Then you have to change the signs. So that's minus and minus now. X squared minus x squared goes away. 4x minus 3x, or 4x plus negative 3x, equals 1x. You can bring down your positive 4. And again, how many times does x go into 1x? So x times what gives you 1x? And that is 1. So you go 1 times x is 1x. 1 times 3 is 3. And when you subtract, those cancel and you get 1. But we don't even care about the remainders. All I care about is this portion, the x plus 1. So my oblique asymptote is y equals x plus 1. And we can put that on our graph. The plus 1, that's my y-intercept for the asymptote. So I just put a little dot at 1 right there. And then the number in front of x, that's the slope. There is not a number there, so we can assume that it's 1. So I need to go up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to change that into a dashed line because it's an asymptote. So that's my slant or my oblique asymptote. Step number 7 is to find the x-intercepts. I'm going to use the factored form because we're setting the top equal to 0. So x plus 2 times x plus 2 equals 0. Remember, if there's two things, you want to break them up and set each equal to 0. We have x equals negative 2. And because it's the same thing, we get negative 2 again. I mean, they're just at the same point. So we're going to write negative 2 comma 0 as our x-intercept. So I plotted it on my graph. Now for the y-intercept is in purple. So y-intercept, we are going to make all the x's equal to 0. So let me use my simplified function because it's a little bit easier, in my opinion. We have 0 plus 2 times 0 plus 2 divided by 0 plus 3. So that ends up being 2 times 2 divided by 3. So 2 times 2 is 4 over 3, so 4 thirds. So you can write this as 0 comma 4 thirds. Put that on my graph. Remember, 4 thirds is about 1.3 repeating. So 1.3 is a little bit higher than 1, so it's just above your slant asymptote. Next step, we have to write the domain. Now, your domain never changes. It's all real numbers, except x cannot equal the vertical asymptote, which is negative 3, or the x-coordinate of your hole, but there is no hole. So it's just x cannot equal negative 3. For the limits, this is where it changes a little bit. the limit as x approaches infinity. I guess we kind of have to draw our graph to see what it's going to look like. Remember that rational functions are still across from each other. So I have 2 points here. I'm going to connect those. I'm going to follow the asymptotes because this is just the sketch. So I have one section of my graph there, and then you're going to go across from it and just kind of sketch that next section of the graph. So as x approaches infinity, infinity is out here, so I'm looking at the very right side of my graph. And that is an arrow that's pointing up. So the limit approaches positive infinity. And the limit as x approaches negative infinity, we want to look at the very left side of the graph, which is here, and the arrow is pointing down. So that would be negative infinity. And we've already taken care of the graphing. We can always check our graph with Desmos. So this was x squared plus 4x plus 4 at the top. That's at the top, and the bottom was x plus 3. And there we have our rational function, which does match the graph that we just made.